everyone. Welcome to another awesome day of FileMaker training. I'm Richard Carlton, creator of FMTrain.tv, where every day is an exciting day in the world of FileMaker because we get to learn new stuff. Yesterday, I kind of sent a report to Claris about it. These guys stuck the landing. It's like watching a gymnast fly through the air, and then you're like, come on, come on, come on. And then they stick the landing and they don't take a step. It was awesome. I really mean that. Yesterday was about, basically, we're going to be renaming it AI semantic search for beginners, right? Really, truly cool. In fact, the whole funny thing about this, we knew that if you go over here to the Terminator, which is kind of a fun kind of thing, hey, we'll throw this in here, that'll be kind of fun. The rub with this is that I came to the conclusion yesterday, and it's not in any way what I would consider AI. In fact, maybe there's AI stuff somewhere else, but the semantic search is just smart math. So I'm going to quit calling it AI because AI gives people the idea that the Terminator is going to knock on your door. Are you Kana? Right? Right. That's how that whole thing started many, many years ago when I was younger. And, everyone's afraid of the machines. This is not a machine that's self-aware. This is not AI in the sense that we would define it. It's smart math. So here's the short version. So let me give you the secret to this, everyone. Okay, here's what AI is so far. Some really smart PhD math people, they came in the room and they whiteboarded this stuff out and did some computer models. They figure out if they do this really fancy math, which sounds like Doctor Strange in the multiverse, right? Because that's what Vince was trying to tell us yesterday, that AI was this multiverse thing with 1,538 dimensions where all these possibilities can exist. And I'm like, that's really just a bunch of smart math. It's not self-aware. So this really should be called SM for smart math, because if you could write a fancy enough mathematical equation, you can do some pretty impressive stuff. And that's what we've got so far. So before we pick up from yesterday, let's talk about the upcoming broadcast schedule. I'm going to press the button. It works. So today is day 2 of really awesome smart math. I'm not going to call it AI, it's smart math. With that in mind, this is the FMTraining.tv website. This data is coming out of a FileMaker database. It's getting a new redesign, but that is DAPI data that's coming out of FileMaker server. Very nice. So you can go to the page. In fact, you can always tell once in a while if there's a big backup running on, you do a reload and you're like, hey, what's the delay here, right? Because at the top of every hour, we're doing a backup on the FileMaker server because we eat our own dog food. And I've got to figure out how to make that backup a little faster so it doesn't pause so much. So let's pivot forward to smart math, AI/smart math/semantic search. And what I'm going to do is I'm going to stop sharing my screen. I'm going to, hey, there's Vince. Hi, Vince. Look at the camera.
Hey.
There you go. Look at the camera. Don't look. It's like, hi, how are you? Oh, you're over here. I'm sorry. And then we got Will. So you two characters are going to Top Gun. So what are we doing today at Top Gun?
Richard, thank you for that introduction and talking about it in terms of smart math, because actually there is a lot of smart math that's going on, and a lot of people don't even know, the people that actually work in it, this is what I heard, they don't even know how it works. It works, but they don't even know how it works. So there is a lot of black magic going on behind the scenes, but it's amazing technology, and it's here, and we can actively take part in it. So we'll pick up where we left off yesterday. We'll do a little recap, and then we'll continue moving forward. Will, take it away.
Yesterday, this is the recap part that Vince was just mentioning. Yesterday, we looked at this simple file that just had one table with one field called strings, and we saw how we could, through 3 script steps, we could configure the account that we were going to communicate with the AI API, how we were going to embed a numeric representation of our data, and then how we could perform a semantic find to actually find records that had some similarity to our search term. So the first thing I thought we might do today is, because yesterday's example is on this silly data with all these random text strings, that I had ChatGPT generate for us, I thought maybe we just kind of dive into a few different use cases that to me actually seem a little bit more useful and a little bit less random. Okay, so my first use case, this is one that I personally grapple with, which is a task management file. So here I have again, a very simple file. There's basically only one field, and each data record represents a task, something to be done. And the issue I find is not just finding the records, but when a user wants to create a record, how do they know that there isn't already a record like it? So the scenario is, I want to have some way to say that when a user starts to create a record, they're invited to craft that record however they like. But then we're going to use a semantic search to suggest to the user, kind of like like if you're on like a call center, like a website where like you try to get to a human being, you try to ask a real question, and they first try to redirect you to some frequently asked questions. So if a user
yeah, that almost never works. So hopefully this works better. So
all right, so let's say I have to write a task that's something like write new security guidelines. So maybe that's a very simple task. I'll say write new security guidelines, and I'm going to execute a search. And so the only extra little magic here that's any different from what we covered yesterday is that it finds records that matches that. And then it gives us this little popover to kind of give us a pivot moment for the user to say, I found 5 things similar to what you just input. Now, either you can click out of this and review those somehow, or you can move forward and create a task based on those records.
Yeah, mechanically, we go through training on this kind of stuff all the time. Not with the semantic search part of this, but with the rest of the mechanics of workflow. This is kind of a workflow thing. I was looking at it, I'm like, workflow is a little weird, but that's not really the point. The point is that you had a suggestion, and basically it's going to say, well, before we commit this suggestion, do you want to confirm that these aren't sufficiently similar to these other ones? And then you would have some sort of way of saying, yes, commit this idea, or, oh, no, it's already covered. Right?
Yeah, exactly.
So this is awesome. I love this. So let's just see what it came up with. Write new security guidelines, update team on changes or data protection. That's not the same as number 1. 2, concept guide for remote network processes. 2 is similar. 3 is no. 4 is conduct audit of no. Create employee training. Yeah, so only like maybe number 2 might. Right?
Mm-hmm.
I'm just reading the way you wrote it. And then so once again, we have our ranking of applicability, or what do they call that technically? The ranking, they don't call it ranking of applicability.
Cosine similarity.
Okay, right here, let me help with this. That sucks. Okay, stop. So I'm now, the AI is now smart math, and cosine, angular, singularity, rotational momentum will now be known as applicability rating. So there we go. I just fixed the world. All right, there we go. Moving along.
I also like the term relevancy. Like how
that's a good one. I will settle for that too. That's good. But cosine, angular momentum of the trajectory of Earth, no, that's not too many big words in one thing. So if you say cosine, everyone themselves because they remember geometry in school. That's an automatic F minus. Okay, I don't know how to make that any bigger. I mean, once again, this is math people who don't know what they're doing. I don't know what to say about that. It's just hideous, right? Like, can I do an F minus? That's a South Park. Right? There we go. F minus. That sucks. But that's because math people built it, not for consumption by normal humans. All right.
So let me move on here. The second, this is one that I particularly like. So the use case here is somebody submits a resume for a position. Okay. And so let's say in that submission context, we know exactly which position they're submitting the resume for. But we also want to be able to consider them for other positions. Maybe we have additional openings that this person wasn't aware of, or maybe they're not well suited to the position they applied for, but we also want to consider them for something else. And so this is where we're going to get a little creative with what so far we've been calling our input. Before, we've been using it as a search term. And now instead, here the records to be searched are these position records, where we have the name of a position, we have a description of that position, like a job position to be filled. And our search term is going to be a resume. So here I'm going to put in the whole resume, and I'm going to do my search. And so it looks at this resume, and it says, okay, the financial analyst role is an 83% fit.
God.
Give resume.
All right.
But so the data scientist is pretty good too.
Can I stop for a second? Can I ask a question? So the applicability rating, or what we call relevance, these numbers, the spread here sucks.
I guess too tight.
I agree. It
It's
could
too.
be. Yeah.
I'm not complaining about you, Will, at all. This is me looking at saying that from the low to high. Okay, can you create another one over here on the right, and then can we update it? Just create a new, new position, and we're going to go through this whole thing because I want to see how badly we can make it. So,
Just
Janitor.
duplicate this layout real quick.
no, I'm just saying. Okay, so let's put in. So clearly. Okay, so we're going to write with the job description of the lady. So whenever I go to Claris at 12 o'clock, she's always sitting there in the lunchroom at Claris, and then she cleans the bathrooms at Claris exactly at 1 o'clock when I'm trying to run in there to go to the bathroom before the live stream. And so she's always got this bathroom. This bathroom is closed for cleaning. So we need a janitorial cleaning professional. Put the word professional. Okay, now where's the description? The description below there?
I would even
My...
remove the word professional, honestly.
Well, you could be. I mean,
just
okay.
Because,
don't
just
game
because
it.
professional. No. Just because professional might be, like a financial analyst is a professional. Who knows? That
All right. Well, then what would we call that? I want to put some realistic data in here, right? So, all right, we lost Will. Are you okay?
Yeah.
Sorry, a lot of building here. All right. So. And if you guys are going to share a file, share this one with the stuff in it. So janitorial, responsible for cleaning bathrooms, floors, sinks, period. Responsible for following cleaning schedule, right? That's a real thing. And documenting the completed tasks. Yeah, that's what they are. Because they have to check off that they did it. Return must follow Cal OSHA. I'm in California. Cal OSHA it's a Cal safety thing. Cal OSHA safety standards for cleaning best practices. Okay, that would be in a resume. Okay, now lose the professional at top. Cleaning, janitorial cleaning, service.
I don't know.
Whatever, that's fine. Okay. All right, now, so this should not in any way do missile lock with the other one. And what I'm wanting to see is what the spread of the ratio is, because we're got a 10% spread, and in real life, if that spread is that tight, we're going to have to do a little math on that ourselves to make it more humanly digestible, if that makes sense, right?
Yep. Okay.
So you need to get the you got a question down there. You're going to have to.
He has to cut the text out of there and paste it back in, I think. Oh, there. No, he's got it. Did it happen?
So.
No,
let's see what my relevancy threshold is.
Yeah, let's do that. Great.
So this is just a reminder that if we don't configure a return count,
it's going to default to 10. Oh, we might have had 11. That might have been number 11.
Yeah.
Okay. Right? See what happens? So, yeah. Okay. What are we going to get? Try it again. Okay. Still not in there. Okay.
Is there a filter? Is there a filter on there?
And a filter on that table, on that portal?
No, I think this is a master detail.
Okay. Well, we need to figure out what it's. Did you went out and got a semantic or got the data for that, the embedded data? Did you go to the embedded?
I thought
data?
I did, but let's double check that. So I'll first just poke that field.
Poke the field. God, there's an old term.
And it's empty.
So you need to run that real quick. So once again, we have as a reminder from yesterday, you just keep going, Will. You put text in, and you're going to have have smart math applied to that text. Once the smart math is done, we save it in the FileMaker file, okay? And then we reference that in the future, right? So we created this janitorial outline position, right? But we never did the smart math. It's where we send out the information out to the OpenAI company with a model information, our account. They charge us 1/100th of a penny, and they send us back the smart math, which is a bunch of numbers. Just take my word for it. Unless you're a PhD in math, you will hate it. Okay, he's doing that. Embedding, got that. He's going to run that at some point. There we go. He's going to bug test it. By the way, this is this is fine. And doing an in-flight adjustment is awesome. People can see this and watch us troubleshoot.
All right, let's try this again. I'll validate that it actually worked, that I have
that you have
an embedding.
There it is.
There it is.
Yeah.
Oh, backup. We haven't seen that before. Is that? Go ahead, Will. What were you going to say?
Oh, yeah, just exactly. I was going to draw attention to this. This is what the extension of the file is that it inserts into that container.
Foxtrot, Victor, Echo, whatever the hell that stands for.
I don't know what it stands for.
It should say SM for smart math. All right, cool. Next.
Okay, so now let's try this again.
Say stop. Okay, the relevancy on this, so what we would have to do is figure out that if these were the top results, and then you'd have to find a way of mathematically spreading these in a relevant fashion, okay? Because this resume has 0% applicability to cleaning the toilet, okay? 0. And so, or 2% or some pathetic number, not 71% valid. Once again, we have to translate the relevancy that we're getting back from from the cosine similarity function. Once again, the big formula that we have, it's a function we call FileMaker. We have to have a way of making that relevant to the audience. And I'm not even sure how you'd want to weigh it, right? Would you want to assume that there was a 0%? Because what if they were all really good at the top, like legitimately? How do you know what's legitimately good, right? Versus, like we cook janitorial, we know it's low, right? But if you didn't know, say like you were from, and you didn't know that janitorial was, So anyway, those are just something to think about for those of you who are rolling this out. You'd want to take the top 1 or 2 or 3, maybe. I don't know what you tell your customer. I mean, Will, what do you do?
Yeah, I mean, one way we might poke at it is on the janitorial position side. Like if we make its description more verbose, like the more text that it has, the more dissimilar it might be from this particular resume, because it might just have more and more descriptions that this resume doesn't have.
Okay.
So we just maybe do one pass of that just to see if it affects, if we change from 71%, whether it goes up or down.
Yeah, you'd have to go in there and do a bunch. You want to do a search on Google for a description of a janitorial position? Service is a word that is relevant according to Beverly.
Okay, so maybe...
Here, I have something. Hold on, give me 1 second.
Okay. All right, well, I'll just try it just with that, just to see if
that helps a little bit.
It has any effect.
Click, click, click. He runs it again, gets the updated stuff. We're going to do it.
All right, so we're at 71. Still at 71.
Yeah. Lynn from Austin has a question. How well does this work to find duplicate names, like the vendor names, ? Does it find names that are the same but spelled slightly different, ? How about a name that sounds the same phonetically?
Okay, that is a great question, and I've got a demo to show that.
I figured you probably would.
Not good.
Okay.
So my demo has people's names, but I can see this applying to vendor names as well.
Sure.
So I did this first test where I put a whole bunch of names in here, and I searched for, I think I did it.
Jennifer, yeah.
Maybe like this. Okay, I'll try Jennifer. Okay, so when this came up, I thought, this is great. It found Jenny, which, okay, those 5 letters are a prefix for Jennifer. But it also found Jenny with a Y. So I was impressed by that. It found Jenna with an A. It found this Austrian, maybe Hungarian.
Oh, back up.
variation.
So I thought that was a fail, but so is that a language? Is that similar than for the language? It is?
That's right.
Okay.
Yeah.
Okay. So far, so good.
So far, so good. But now, watch this. It finds 0 records for Will, even though a native FileMaker search finds Williams, which you might expect. It finds Williamson, Willis.
I have a question. So is this the model that because back up, okay, Jenny or Jennifer clearly is a name. The word Will is also a noun for a document when you die. It's also if you have the will, there's a way. There's other uses of the word will. Could you train or have the model that's focused on naming as opposed to, you see what I'm saying, right? As opposed to, because it doesn't know what the context is of that.
I only researched that lightly, and I did see an indication that there were models that were trained on names that would be better suited.
Okay. Because that's the difference here. Like if you do Richard, just for example, Richard is not like some sort of Diet Coke or something, right? Okay, so then do a search for Richard over there. Do we have any Richards? All right, so we need a better model for names.
And to me, it's like, how do we then kind of have the two coexist? Like if you want your embedding to be a summary of your entire record, some of which are text fields, some of which is like a person's name, where we might want to leverage different models. That's a challenge.
Well, the easy answer is that you're going to have an embed for each model, right? Once again, this is can you just, to remind everyone of what we saw yesterday, can you show a piece of text and the matching embed for that somehow?
Sure.
Just to remind people what that looks like. So the embeds are basically the smart math, right? So if I put Quentin Richardson in there, there is some smart math that correlates to that. And that smart math, but this embedding is the smart math specific to right there a model. Does that make sense? So if you had like a names model and say you had medical devices or medical related model, right? I'm just saying if you had a different LLM, right?
So as like an actual like model that was trained on like
yeah. You'd have to have an embedding for each model. So if you're using like a names model and a medical model, because maybe in another area, and then maybe a jobs or resume focused model, that you could pay for that through OpenAI, very cheap. But you'd have to have embeddings for each one, which means that you'd have to come up with this way of these containers being kind of part of that, right?
And that would also mean that when you perform the semantic search, you're basically searching on a single column at a time. Like this is a medical-based column with its medical embedding.
You are absolutely correct. This is a basic live stream. We're solving the problem's easiest first. If you want to actually have it be super smart, where you're searching across multiples and then somehow cross-pollinating the results with multiple, like calling 3 or 4 different LLMs at the same time to see. And then I'll take a vote in a room. Take a vote. Hey, which one do you guys think this? All right, we're going to vote. Raise your hand if you think this is valid. That's a whole nother can of worms. So now you have the smart math trying to aggregate the smart math in a smart way. Oops. Okay, I hurt my head.
Another approach, like let's say we didn't have access to a better model and we did want to have some kind of high level search field that searched across multiple fields at the same time. We might do something where we either perform the semantic search and then extend the found set to include like a native FileMaker search.
Yeah.
Or something we didn't do yesterday, we can, and actually, sorry, let me, I like this example. Okay, so we have the option of saying, I want to perform my semantic search on all records, which is what we've done so far. Or we can do it on the current.
So that's a constraint, right? That's a constraint right there. Yeah, but there's
you can say like, first I'm going to find Richard, as a field, and then I'm going to perform the semantic find, to constrain that further.
Yeah, I got some Bev action here. So here's Beverly. Many people might narrow the search set from a FileMaker found set first, and Soundex, so Soundex, does a great job of encoding based upon phonetics. Soundex is used by the U.S. Census Bureau. They're the ones that count all the people in the United States to get similar. So already you have a near match. However, there may be models that will be heavily into name variation, so you can check that out as an option, right? So good job on that.
That's great to know.
Yep. Yeah, that's why we have smart people who come to the show. All right, cool. All right, you want to continue on with your demos? Move on to the next demo?
Sure, you bet. Okay, and the third one I thought would be interesting, and we touched on this a little bit yesterday. I've been calling unified search, which means to search across multiple tables. So, there's various ways. This is independent of semantic search, but I think semantic search adds an extra nice layer on that. So here's an example where we have a layout that is based on a table that each record in this layout is a shadow record that looks to some other table. Like this record looks to a person named Aaron, but down here, this record looks to a project in a project table for AI-powered dream interpreter. And so structurally, up until now, for a project, we would have had the embedding in the project table. And for the person, we would have had the embedding in the person table. So what's different about this example is I created an embedding table. Each record has its embedding stored in this table, and this is the table that gets searched. And so what's kind of cool about that is then you can say, from my perspective, like I want to use semantic search to take the burden off my user. I don't want my user to have to think about how the data was input into a field, what words were used. And I'd be interested to see, like, I don't want them to have to think about where I stored the data. I don't want them to have to think about the data structure itself. So if they could do a semantic search and search across a whole bunch of tables all at once, I think that would be a win for a user. And so I might do something like, I'll say green energy. So here we get a list of, looks to me like just projects. But let's say I look for something having to do with water. And now we get a mixture of records. The first one is a surfer video. It's not searching the video, it's just searching the description of that video. We have a project that has water in the title. We have a person who has a hobby of aquascaping. So to me, it's just kind of neat to be able to.
So this layout's attached to that embed table. Is that what we're doing? We've done that?
That's right.
That's okay. I had not thought of that. That is smart. So he's mixed together all the different various things. And so when he does a search for water, he come up with people, places, things, invoices, projects, God knows what. Okay.
There is an interesting gotcha here, though. And this is one of the ones, I don't think we've really talked about performance yet.
Go ahead.
There's a performance cost to searching on an embedding through a relationship. So here I'm searching on the embedding table itself. There's no performance hit to that. It's no different from anything we've been doing. But what if in my context, I say, okay, but I just want to search on projects. So here I'm actually sitting on a project layout. So these are project records, and I can do the same search here and only get projects related to water.
Okay.
But it's doing that by doing the semantic search on a related field, the related embedding record for the projects. And in my testing, that gets slower the more records that you're searching on.
Can I ask a question? So normally with containers, we do, this is for the FileMaker community, it's a new use of containers, to be clear, okay? And we don't normally search on containers because really, what are you going to search on? Give me 5 blue pixels in this specific spot. We can't do that. So, but now we're searching on containers, which brings up a really interesting question. Is there a performance? Okay, clearly we have internal containers versus external. I spend a lot of time beating on people and training about that, right? Internal are great for brand new people. And then as soon as you're past the brand new stage and you start using containers in a meaningful way, they need to be saved externally. So how does the semantic search against containers affect internal versus external, and then frankly versus secure? Because there is a little bit overhead of decrypting the container.
Yeah, and I haven't tested it, but in a recent one of our Claris office hours on AI, there are some people brought up in their testing that external storage was slower than storing it in the file itself.
Yeah, I really hate saying that. I really hate saying that to people because the reality is that they're gonna. I mean, how big are these? Okay, back up. So we got the smart math in a container. How big are these files?
Yeah,
right?
Great question.
Okay, back up. Go back to the resume if you want to bring one up. So the resume is a page of text, maybe 2 pages of text. How big is that? Is that not PDF? The FVC or the F? How big is that? Do you know?
The interesting thing is it doesn't matter how big the text is. Like encoding the word water versus that entire resume.
No, I get that.
Footprint.
I get that. But my problem is that the reason we use containers externally is because as soon as you put a lot of stuff in there, you balloon the file, backups get slow, and the whole thing takes a So we don't want people sticking stuff internally unless there's not a measurable penalty for that, right? You see what I'm saying? So how much of a penalty? Are you going to share these files at all? Right, where people can download them and then sign up for your newsletter or something like that?
I just posted them in the Discord chat. All three blog posts by Will are there. But yeah,
perfect.
So that's the easy reading part while Will was doing that. I'm going to post one more link and that is the PDF or the document that all this explosion of AI came from this one research paper called "Attention is All You Need." So, for those of you who like bedtime reading, really
Okay.
deep subjects, that's where it all kind of exploded from.
Back up. So you were saying what comes from this? All this smart math stuff.
Oh yeah, all the smart math, all this, like a lot of what we're having today is the outcome of the culmination of that paper, basically, from a lot of people, from Google and that kind of thing. And
Okay.
you can use ChatGPT to say, hey, can you explain this paper in layman's terms? So like make it simple to understand. So yeah.
Okay.
But Michael had some interesting comments. He had a comment before I posted all my blog posts. Or you embed all the data into one field, but you have labels associated with it. So this kind of touches on another subject that we also kind of at least I learned in terms of generating these embeddings is if you have like these single words, or you have like in a database, you have a lot of attributes sometimes, right? So you'll have the project due date, you'll have the project description, you'll have the project budget, so all these disparate things are scattered in there in the database, right? These are all attributes of that record that make up the project, right? And so one good way to think about this is take all those attributes and turn it into like a story. Like this project, and the title of this project is such and such, and here's a short description of the project. The project is set to start on this date and end on this date. So you'll end up with like a small description of what this project is. And then you build an embedding based on that, rather than think about building an embedding for the project description, or think of building an embedding for the project title. And you know what I mean? You know what I'm saying? You want to kind of synthesize it into one concept.
So you're saying you're writing a natural language readable version of your data, of your record, right?
Yeah, and what Michael is suggesting, you can also have those labels associated with it. At least that's what I understood what he mentioned there.
That's interesting too. Yeah.
Yeah.
Well, you'd want to say, well, and the due date is this, and then this is this, and the budget that was forecast was this. Yeah. That would make sense, because then it would parse that apart and use that. So we have a couple questions from Alex Spring-Connell. Would the model used, as in which model that you get from OpenAI, result in a more realistic spread in relevancy scores? ? My answer is maybe, probably, but will you?
I haven't tested with other models, but I'd be very interested to see if that does affect the spread. So I can't answer that, but I want to pursue it.
Next question Alex had, I actually had this from yesterday, which gets back to this container kind of question. So the size of the embed file is dependent upon the model used, right? ?
That's correct, because the model used determines the number of dimensions, which just means the quantity of numbers. And so the more dimensions, the more numbers, which is basically a larger text string to be stored. And I'm actually surprised here. I just exported this one embedding, and it's only 16 kilobytes, which is a lot lower than what my earlier testing was. So there's some flaw in my earlier testing.
Well, to be real about this, so if I had, listen, back up. If we had containers, and all the containers in the world we'd ever had were all 16 kilobytes, we never would have made them external. They always would have been internal. So in a case like this, I'd be inclined to leave them internally, but they're not. It's not, to be clear, everyone, listen, everyone, I'm not endorsing internal containers for photos and resumes and things like big documents. I'm saying if you have an embed, and it's a container, which FileMaker is designed to work this way, then that can be internal, right? Because it's so small and snuggly that it's really not a thing. I don't
know if that 12 kilobytes is representative, or sorry, 16 kilobytes is representative of the size of what that that attachment or that container file is.
Okay, so I'm not as
Yeah,
smart as you,
so
Vince. What are you saying? You're saying that that says 16, but it might be bigger or smaller. What are you thinking?
I don't know, like
Or you think it'd be different from record to record?
no, it would be consistent because it's going to be the same numbers. It's 1,537 or whatever that number was.
Dimensions
Yeah.
in the multiverse,
Dimensions,
yes. So
36.
Yeah.
So at least for this model, right? It's going to be different dimensions for different models, but for this model, it's going to be those number of dimensions. So, I would probably just to compare, what I would do is I would get the embedding text and save it into a text file, and then see the
okay.
size, and then see the size of that text file. But maybe maybe this FVE file format is really a compressed version of that, and maybe that's what it is. Maybe it's how in the past they used to have zip files and whatever tar files and all that, and maybe there is a way to save it as a very compressed version, and maybe that's what it is. And so it doesn't take up a lot of space, and maybe that's why it's so efficient, and it doesn't matter that it's stored internally. So
Yeah, if it's small and fast and no one cares, as soon as it gets big and ugly, it's when we have to have externals. All right, so here we go. He's going to grab that. Here goes the test.
Yeah, I'm curious to see how different it is in size.
Wow, this is great stuff.
So, kilobytes.
It's huge.
Well, not huge. Come on.
Well, okay, relatively, it's almost, it's not quite, what, 900% bigger, 800% bigger, something like that? Yeah, that's pretty damn large. That's a lot larger. Once again, in a small file, but I'm thinking about 1 million records with this in it, right? What if we had 1 million records and you embedded 1 million records?
Oh, Michael said something else that's worth mentioning. He said some models allow you to control the number of dimensions so you can make the embeddings smaller.
Yeah, I'm assuming if you cut down dimensions, there'd be penalties for that. So it wouldn't be, so you'd have to figure out where the sweet spot is. Sounds like some QA kind of testing and beating your head against the wall. Yeah, there you go. So yeah, this is pretty small. This is really good material. I don't know what you guys were planning to do today because we're chewing right through it, lickety split, but this is super. Is everyone, okay, back up. For everyone who's new here, not Beverly and Mike and a couple of the super ninjas, how many of you have basic questions you don't understand, like what the hell we're talking about? I need you to raise your hand. I will not make fun of you. How many characters per dimension? Alex asked the question. I don't know. What was it? I'm assuming that's one dimension right there. So
that's right.
That's, I don't know, 15, 20 characters. I don't know, whatever that is. Length, right? Length function. Yeah, 26. Okay.
And it would be, if it was not a negative number, then it would just be 25.
Mike says Todd Geis in 300 dimensions is plenty.
Just to go back on that point, yesterday, at the end of yesterday's call, we also discovered that this works in multilingual aspects.
Ooh,
remember?
Yes.
Yeah. So I wonder if a smaller dimensionality would be able to support the fact that you have a Spanish user and a French user, and they'll typing in French or in English or whatever. They'll be able to find the matching values. So that's something to look out for. But yeah, how many ways would you be able to document or describe something? And especially, I think these descriptions are for all these based on all these tokens, I guess.
Yeah, there'll be a penalty you pay if you go from 1,500 to 300. Rick Fosna says, I am listening, but I need to gain a foundation on how this will work for me. So if you watched yesterday, you watched today. Today is kind of, so can you bring back your samples folder real quick, Will? We'll just talk about this high level real quick. So his demos, so he has a demo where we're talking about someone writes a string of text, like a to-do, and it searches for similar to-dos that are in your to-do list. Like if my wife gives me do this and do this and do this and this, and it's getting out of hand, so I build a database for her, which would piss her off, right? And so, but then it would say, honey, you've already suggested this before, right? So it might help you with that. Related data, we haven't talked about that. Unified search is searching across multiple different areas, but the idea is that it's not a super precise. I think the best analogy we had yesterday was like doing a Google search for something. Google might give you really great results, and they might be hideously, horribly bad. So this stuff is a loosely a suggest, like the resumes, right? We did a assuming. Bring up the resume thing real quick. This is such a great one. Just stick a resume in there real quick one more time. So we have one problem in here that I have an issue with, other than that the little relevancy factors on the side are too tight. They need to be spread out more meaningfully. That being said, this is a super common request for HR departments. Now, they probably pay companies, and now every company like Zoom, I keep getting calls from Zoom saying, if you'd like our automatic AI to do this whole stuff, then give us another, $1,000 a month for this. So everyone's trying to upsell their products with AI and then take your credit card to the cleaner, right? I get that. I get all that. That's fine. But this is a real common request. Try to automatically find the things that are most relevant. So if you put this in here, this is not, once again, a precision system. It's like a Google suggesting to you that, yeah, it's probably these first top 3 here are probably good. And then as you go farther down the list here, because that janitor down here is still less than 71, and that has nothing to do with cleaning the toilet, nothing. So it has its uses. It's a good suggestion tool. So Rick Fosna, I'm talking to you, right? Yes, we follow that? The idea is to make it kind of human readable, right? Alex Connell says this has been a very useful. I love the idea of narrating the data to create a human readable, and then you feed that into the open AI for the embedding, right?
Richard, on that last point with the narration, can I show another quick example here?
Oh, please. We don't. There's not a hard stop. I just making sure that people are starting to feel comfortable asking questions, and I want to make sure their questions are getting picked up.
In our demo yesterday, I was showing how I used the insert, embedding, and found set script step, because that was just an easy way to say, for my whole record set, update everything. But, sorry, let me go back to yesterday's example. So here's where we did that, insert, embedding, and found set. But some interesting nuance of this is that we pick a source field. It's not a text string. It's not a variable. It has to be a field. Now you can create a field that is concatenating all your records data, but if you're storing that field, suddenly you're like doubling the size of that record. So another option here is the insert embedding script step, which does it for a single record. You can do this within a loop. And that script step is different because it takes as an argument a calculation. So you could feed it one field, you could feed it multiple fields. In this case, I'm trying to build that human readable string to kind of narrate the record.
You could also put a variable in there, right? So you could set a variable and then put that in there. Okay,
that's right.
So back up. So what was the script step? It was the insert embedding. Okay.
As opposed to insert embedding and found set.
So this one we had to do a loop because it's not on a found set. The other one kind of does its own kind of loop for us, right? More or less.
It's not because it's not a found set. It's that I wanted to reference more than one field in the embedding.
Right.
So here I want the name, the state, and the hobbies, and I want to put this text around it to help the embedding model understand what these fields are in relation to each other.
Seems to me this would be the more professional one we'd want to use most of the time, right? I mean, I'm talking out loud, but yes.
I think so, because like that strings example, it's going to be so rare where you just have one field you want to search on.
One field, yeah, no, exactly. From Vince, I'm just quoting Vince here. Binary files is a container that is text, but it would be similar to a graphic file PDF. Remember that there are metadata with files that would not be in the binary encodings. You want to expand upon that briefly, Vince?
I mean, I'm just quoting what Beverly sent to restate it, because basically it might be that it's really efficient, and that but that will be smaller than a file that is a graphic file or PDF file. Right, so that it's just
sure.
So it'll be very efficient. Okay. Yeah, so go like I mean we're almost done with time, but I just want to bring kind of like a big picture overview to all this, and that is this is a lot of this is new. I mean, this is new for FileMaker, but this is new. This is happening in the field in the world in general, like this whole AI revolution, right? So we're at the very beginning, sort of like embracing this in FileMaker, at least not at the very beginning. But what I'm saying is now we're starting to play with it. We're starting to learn these concepts, and just like maybe some terms that you're new to databases, and what is an index, or what is a field, what is a record. These words, embeddings and semantic searching, are going to become as common as like words like record and field and index. In a few years, you'll see that these are just commonplace. But what is also interesting is what you pointed out, which I agree with you, Richard. I mean, what is it? What did you say? The relevancy score for janitor in this resume. I mean, it should definitely be a lot less relevant, and it shouldn't match it. So there's definitely room to improve.
Yeah.
In those models, and they will get better and better.
Part of this is the fact that we don't know how. I don't have a description of how that ratio is calculated right now internally at or within that cosine thing. And I don't really want to know if I want someone to walk me through the math on it, because at the end of the day, I don't particularly give a I have to deliver solutions, and if their math is off in the weeds, I'm not a paid math. I mean, I'm an engineer, but do I really want to sit and do math? But I'm just looking at this going that ratio might be for the scientific mathematician ratio, but the human readable variant of that is going to have to spread that number out, right? Because if we know the top one was good and the bottom one was bad, so we could cook our own formula here with that if we knew that, right? We could say, well, let's make 71 like really low and the other one really high, and then distribute it appropriately in between. We could do math on that. That's not that big of a deal, but we had to know where the top and bottom limits are. Where's the limit of that equation, top and bottom? How are you going to evaluate it top to bottom? There's a calculus thing.
We have two things real fast. Oh, sorry.
Go ahead.
I was just going to throw in, I have an example in that part 3 of my blog, Richard, that kind of goes down that path of saying, I take like a body of records that I say like, these are good results. And I compare it to those, and I say, how many of these good results does this one relate to with at least 80% relevancy? And so if I have 100 records and it relates to 8 of them, I give it a score of 8%. And so suddenly we get this huge spread from like 0 to 100, where like all kinds of garbage floats to the bottom, and the really good stuff rises to the top.
Absolutely. And so you have to kind of you have to deliberately cook a test. We have to cook a top and a bottom so we know where the limits are, right? Where we know it's perfect and we know it's and then you know how to spread those numbers in there. Like if you realistically knew that these were great, you could say, like, you'd have to come up with an idea that the financial analysis is 95%. We just say 95, and we say janitor is 5%. Then you'd figure out the spread between each of those, and you'd do the basic math on this to spread them out. You could do it, but you have to know both ends before you can do that math. Well, I really, people say, why did you get a degree in engineering? I'm like, well, because I thought it might be useful. Here I am. It's back to being useful, and that's 30 some odd years ago. So, damn.
Okay. So real fast, Beverly wanted me to make sure that I read something. So a binary file in a container, that is a text. Embeddings equal numbers, yes. But that will be smaller than a file, a graphic / PDF, etc. Remember that there is a metadata with files that would not be in binary embeddings.
Yeah, so she's saying that the short version of that is that if you have graphics in a graphics file in a container, that'll be always much, much larger than this text-based embedding file, which is fine. Once again, I'm thinking about millions of records here. 500,000 records, I get interested, because that's where historically you're going to start, well, you can get in trouble with 50,000 records, but yes, most of us, that's why I try to train. I don't really worry about small numbers. They'll always work good enough. But when you start dealing with millions of records, yeah, so.
Remember, like you have a record with multiple fields, multiple attributes. If you update that record and change the end date or change the description, you want to regenerate the embedding for that record. And that's what that step is. Okay.
Yeah, so this gets back to this idea. People, I was jumping on someone the other day. I don't know who it was. It's Hot Air Balloon Ken on the show here. And he was like talking about, well, I'm going to do all this stuff, and I'm going to do it in calc fields. I'm like, no, you're not. Stop. Put your mouse down. If you have a bunch of data, text, number, date fields, and you want to do a bunch of stuff with it, you write it in a script. And then you trigger it appropriately so you control it precisely with the script. You don't want it running behind your back in a stored or unstored calculation. It'll just make a mess out of it. So, and in this case, we have to do it that way because we have to call the calls to the service provider, whoever the service provider is a scripted call. This has to be moved out to a script. You don't have it's not a negotiation here. For those of you wondering, how do I put this into a calc so I never have to have a script? So there are some of you who do that.
Actually, just to qualify that, I think in a few examples we used the get embedding function. So that is a function that can do the same thing the script step does.
Yeah.
So you could do it as an auto enter calc.
As an auto enter, yeah, and that's what Ken ran into yesterday. So I'm very leery about that. In some cases it works okay, but I'm always a big fan of the idea is that once you get from beginning to intermediate, you need to start precisely controlling when calculations and things fire in FileMaker, because it will frequently do it when you don't want to, and it causes your solution to slow down. So I love things that are scripted. I love to mostly remove calculations out of solutions almost entirely and run it from a script and a precision with triggers. So that's just me. All right, cool. Anything else from Beezwax? You guys have really killed it last couple days. Really a great job.
Yeah, from my end, I would just say, like, if you have time, just try to skim through the blogs that Vince cited, because there's like lots of nuances to these that we didn't have time to cover, little details, other configuration options in those script steps that maybe we didn't get to. So I think just, once you've kind of got a good basis with the stuff that we've already covered.
For the record, you guys are welcome back anytime. Let me know. Vince is going to be back anyway, talking about his new updated
Inspector
version
Pro.
of Inspector Pro, which is some sort of fangled, amazing thing that Vince told me that all you have to do is think what you want to do, and it will build it for you. And so I thought that was worth a lot of money. If it's just like telepathic sensory input, that was awesome. I pay for that. So he will be here showing Inspector Pro with telepathic input in July, right? Sometime in early July?
Yeah, 2027.
Yeah. That soon. That would be awesome. Will, if you ever want to come back and do that, let me know. But you folks brought this down to such a simple level. It's very, very useful. We greatly appreciate it.
Thanks so much for having us. This has been really fun.
Well, hopefully it is fun, and you can go back and forth with the audience, and that's great. All right, that's it for today. We'll catch you tomorrow with Corn Walker from Proofgeist. All right? See you.
Thanks, Richard. Bye,
Thanks, everyone.
everyone.
Menanno